Hello everyone, welcome back to the Zeus Developer channel. This is the continuation of our 3 parts video where we're deploying an EKS cluster, that's a AWS Elastic Kubernetes Service cluster, right? And running a workload. In this video, in this second video, we're setting up a load balancer, for our application, right? And then in our third and final one, we would set up external DNS so we can connect a domain name to our application. All right. If you remember from where we stopped in the last video, we deployed our app, but we could only access it from our local system, right, via port forward. The application wasn't accessible anywhere. And that's what we want to change in this video. So we're setting up a load balancer. I remember I briefly talked about 3 types of services in Kubernetes. Let me show you an image to explain further. So these are the 3 types. We have a cluster IP. So for cluster IP service, you will have your ports only accessible within the cluster, all right? So maybe like port-to-port communication. So you can access the port with this type of service, from the outside. Then the second service is a node port type service, right? So with this, you should be able to access your application, all right, via this service. But that will also depend on your setup. Are your worker nodes in a public or private subnet? Are they private or public worker nodes? If it is private, if it is public rather, you'll be able to access it anywhere from the internet because you are going to have an external IP. But if your worker nodes are in a private subnet, which is the situation in a typical production environment, you won't be able to access it from the public. All right, you can only access it within the VPC in this case. And then the third type, it's a load balancer type, right? So for this type, this type is meant for cloud providers, right? So if you set up a service of this type, what happens is your cloud provider, be it AWS, Azure, or Google Cloud, they will provision a load balancer for you, right? And automatically you would have a load balancer URL to access your app or your service. And then for EKS or for AWS, we have 2 types of load balancers. We have the network load balancer and we have application load balancer. Network load balancer is operates at layer 7. It's a TCP load balancer, while application load balancer it's an HTTP load balancer operating at layer 7. Did I miss this? This is layer 4 rather. Network load balancer is at layer 4 while ALB is at layer 7. So moving on, again, if you set this service type to load balancer, your provider provisions an NLB for you. But let's quickly see how that would happen. If you come here now, we see that we have no load balancer, is empty here. Let's quickly set our service type to load balancer. Remember the last time it was at node port, right? So if we come here and quickly go to service, open it up with nano. Remember this where we left things. So we're going to set it to load balancer this way. This is a Pascal casing, and just update it. Right, so we write it out. And then apply this this change, right? And we hope to have the cloud provider provision a load balancer for us. It usually takes a few minutes for that to be provisioned, so I'm going to come back when that is done. All right guys, load balancer, it's ready for us. So look at this here. So if we go back to our service, right, and view our service, we should see the load balancer URL with which we can access our application. Look at this. So external IP here, we have so let's grab this guy here. It's a long URL. Right, open the browser tab, go. Remember, it's not secure, so don't put S in your HTTP. So voila, so this is an app, right, from a load balancer type service. All we needed to do was to create a service of load balancer type. So meaning if we change this back to node pod, it will automatically delete or deprovision this load balancer, and this URL will not work anymore. All right, now that is that, but there are cases where you will need to set up a path-based routing. What do I mean by that? Yes, so in a case where you have different services, all right, and then you want to set a different path, say you want to set /auth to service A, you want to set /cart to service B, in the case of maybe e-commerce, maybe payment, checkout, different service. So to be able to do that, Kubernetes provides us with another object called Ingress. So Ingress helps you to create a path-based routing where you could set different paths, pointing or mapping to different services. But to do that, you would need to provision a controller, right? A network, an application load balancer controller by yourself in this case. Remember, for load balancer type service, your provider provisions a network load balancer for you, right? This is done for you as soon as you create a load balancer type service. But if you're going to work with an Ingress, you will need to provision or create your load balancer by yourself. And how do you do that? You do that with a controller, right? So think of controller in Kubernetes as a task or processes running, and what they do is to watch other processes, right? To say if something changes in process A or service A, it will maybe alert another service, to make an update. So that's what controllers do in Kubernetes. They watch different services. It could be something, a service in your cluster against an external service outside, all right? So as soon as something happens, if something changes, it will update that service or that process outside of your cluster, right? So we're going to install a service. In fact, that's the main thing, the bane of this video. All right, so how do we do that? How do we set up an Ingress? So there are a few steps we need to go through, but not to worry. I've gone to do some of these things. Because we need a special a role with special policy, all right? So that policy is downloadable on the internet. I've downloaded it, created the policy, I've created the role, I've added the policy to the role. Those are things that anyone can do, right? If you know your way around AWS. And then I've also created an OICD provider for the cluster and added it to the role as a trust principle. Maybe some other time I'll talk about authentication and authorization with Kubernetes and AWS, how they work together, when it comes to authentication and authorization, right? So all of this is done. So we're going to continue from number 3 here, where we're going to install the controller. We're going to be using Helm program that I told you about. This is a package manager for Kubernetes, and we're going to annotate it with this role. This is the role. like I said, it's already created for you with trust policy. This is the policy that was created. This is the role. So we're going to annotate. We're going to supply this role to Helm to help us create a service account, and then we're going to tag our subnet. We're going to create. Okay, this is done. We have a service, right? Right now it's load balancer type. We're going to change it to either cluster IP or node pod. So we're going to do that, and automatically AWS will deprovision the load balancer they created for us. And then we're going to now create an ingress object or resource with some annotations, and when that happens, we will have our cloud provider provision our application load balancer for us, right? And then we can get our load balancer URL to access our application. So let's start from number 3 here, or continue rather, because 1 and 2 are already done. So we're going to install with Helm. With Helm, first we need to bring in a repo. So I've already done this. Maybe we'll need to update this. Let's maybe run update, because this is already done. If you set this now, they will tell you, oh, you've already added this repo called EKS. So let's go and let's clear first. So yep, the repo is up to date. So let's now run the main install command. Now let's go through this quickly. So this is what we're calling the release, and this is the repo we're installing from. So we're installing it, this controller in this kube system namespace. This N is for namespace, and then we're setting these values, right? So we're giving it the cluster name. Remember the name of our cluster, EKS cluster 07, and then we're passing the name of our service account that we need to be created. So this command will also create this service account for us and do some other things, right? And then we're passing the role, right? The role that I created before now. I'm passing this role here so that it will annotate this service account with this role, with which Kubernetes can access the AWS account, to provision the application load balancer. Okay, and I'm as well passing a VPC ID here. So let's grab this command and just run it. Hopefully there is no mistake anywhere. All right, let's see what next while this is running. What did number 4 say? Tag our subnets, right? So remember, what's going to happen here is going to create some resources, service account, cluster rule binding, and then but ultimately it's going to create the application load balancer, with using this role. If it doesn't have this role, it won't have been able to do that, right? So it's going to do that. But now we need to also, the fourth thing we need to do is to tag our subnets. Remember, we have 4 subnets, 2 private, 2 public. All right, and this is how you need to tag them. So the public subnet, you need to give them this tag, right? This is the key and this is the value, right? The 2 public, the 2 private, you need to tag them with this key and this value. Then for all 4, we need to tag them with this key and with this value. Here is supposed to be the namespace, but again, I've also gone to do this. If you check our subnets, all of them have been tagged accordingly. I passed the EKS cluster 07 here as our cluster name. All right, and I used this AWS CLI command to quickly tag resources like subnets. All right, so I've done that, but let's go look at our Helm install, see where we are. Right, it's been installed. Hey, it's a load balancer installed. All right, so let's continue. Again, number 4 is already done. I've tagged our subnets. That's something easy to do. And then the 15 is to create a service, which we already have. We already have a service, right? But what we need to do is to update it. You know, it's currently as a load balancer type. So let's go ahead and edit it with nano again and change it back to node port service. Node port. Write out and exit. Should we apply it? Yes, let's apply this already. Kubernetes, let's apply. Yep. So we've updated it. We're applying it now. Let's go back and see what next to do. So we'll create the ingress with these annotations. All right. This when we're going to look at an ingress object. All right. So I have an ingress manifest as well in this same place. So let's open it up with cat and see it. Let me clear my screen first. So look at the ingress. The kind, of course, is ingress. Look at the metadata, the spec. I'm coming back to this place here, but look at the spec here. Ingress class is ALB, that's Application Load Balancer. And this is the rule. So look at this here. This is where you define the path, as I was talking about here. So here you can say /auth should point to service A. Then you can add another path. This is a list of paths. You can say now /cat should go to service B. So here we're just using slash, so we're not putting anything. This is an index path. So this index path should go to service, this index service. Now this is the name of our service, and then if you remember, the port now is port 80. We've updated it to port 80. Before it was port 8000, but now it's port 80. So you need to specify the name and the port of the service you want this path to map to, right? That's this bit. But now this other bit, this annotation is very key, because if you don't get this right, nothing's going to work. So 3 annotations here. Annotations are usually how you have a Kubernetes object, talk to maybe an external service. All right. In this case, it could be AWS now, or EKS. So we have these annotations. Internet facing type is IP, and then subnet will supply public subnets here. So these are my 2 public subnet IDs. All right. So if this is good, we're going to apply it as we usually do. So apply -f ingress, and we should have our ingress created, right? So what's happening now, or must have happened, it's our load balancer, right? It's already been created, or it's already, a load balancer is either ready or being created. All right, guys, our load balancer is already active for us. All right. So what's the next thing here? If we view our ingress now, we should be able to see the load balancer URL with which we can access our application. Remember, this is what we just did. We annotated the ingress and created it, and it's in turn created the application load balancer for us. So let's go view our ingress and check if we have a load balancer URL. Let's clear first and hit this command. Voila, we have our load balancer URL for us. So let's take this, open the browser, again HTTP, so it doesn't automatically add S. So here is our app, and that's how it is, guys. So remember what we've just done, right? We set up an application load balancer, and the way to do that, right, is by using Ingress. And how do you create an Ingress? Create an Ingress with all of these annotations, right, with pointing to the service, right? So our index route is pointing to our index service, right? And our index service, it's our service rather, it's the NGINX service, all right? So when we go to this index route, right, we're able to see our application. All right, so hope you learned something from this video. And the next video we'll wrap it up with setting up an external DNS, meaning connecting our service to a domain, so we can go to our domain and access our application. Please don't forget to like and subscribe, and I will see you in the next one. Bye.